Hi everyone, this is Mrs. Tiglis, and today we are going to be talking about comparing and ordering rational numbers. I may end up splitting this into two videos. We may start with just comparing, and then I may do the ordering as part two, but we'll see how things go. So first of all, this notes page talks about common and least common denominators. I don't think we need to redefine that. We've already been doing a lot of work with fractions this year on what common denominators and least common denominators are. So just know that we are going to continue to use them. Some new vocabulary, though, is going to be rational numbers. Okay? Now, rational numbers are pretty much almost all of the numbers that you think of. Okay, that you've learned about up to this point. So some examples would be just a regular fraction, a regular decimal, repeating decimals, percents, integers. Those are all types of rational numbers. Okay, now they include this diagram here that has whole numbers, integers, and rational numbers. And what you're supposed to see here, or what it's supposed to visually help you understand, is that if you have a whole number, okay, that's like a number you would count, 1, 2, 3, 4. Those numbers are always going to be integers, and they're rational. So any whole number is always an integer and a rational number. Okay? If you have an integer, though, hopefully you remember the definition of integers. Integers are whole numbers, they're opposites in zero. So an integer could be a whole number, but not necessarily. Okay, it's always going to be rational though. So an integer is rational, but not necessarily a whole number. And then rational numbers would be anything that's not an integer or a whole number. So a lot of fractions or decimals or percents. So let's quickly fill this in. I'm gonna make it a little bigger here. It gives us a number bank, and the first number it gives us is 8/10. Well, 8/10 is going to be a rational number, okay? It's not an integer and it's not a whole number, but it is rational. It's just a regular old terminating decimal, okay? So we've taken care of that one. The next one, 2 and 2/10 repeating, that would also be a rational number, okay? Remember, repeating decimals are rational numbers. -1 would be an example of an integer. So I should probably make this extra clear here. We want to define these numbers the most specific way we can. So -1, although it is rational, it's also an integer. So the most specific way to define it would be an integer. So that's why it needs to go in the integer circle. Okay, next, the number 1. That's just a plain old whole number. So the most specific way that we could define that is as a whole number, although it is also an integer and also a rational number. And then finally they give us the mixed number, 1 and 2/3. That would be rational. It's not an integer and it's not a whole number, but it is rational. So you may be wondering now, well, if everything I know is rational, then what's the opposite of that? What is not rational? Well, in math, we call those irrational numbers. And the most common irrational number that you hear about is pi, okay? Because pi is a decimal that goes on forever, and it does not repeat. So it's not a repeating decimal, it's not a terminating decimal, it would just be an irrational number. So pi is an example of an irrational number that would not fit in that original chart. This real world link here says use the internet to search for the digits of pi. If you're really interested in doing that on your own time, you can. We're not going to spend a lot of time doing that now, but what you'll find is some websites, they'll have like over 1 million digits of pi. And again, it's because it keeps going on and on forever without repeating. Okay, so let's go on to the next page of our notes, and we are actually going to start comparing some rational numbers. So this first problem, it says to fill in the circle with the less than, greater than, or equal sign symbol to make this true. -1 and 5/6 compared to -1 and 1/6. Now, the easiest way to see this is to use our handy dandy number line. Okay, so in this problem, they actually drew the number line for us, which was really nice. Hopefully you know that these two mixed numbers are between -1 and -2. Okay, and then all that you have to do and in this case it's done for you, but is make all of the fractions that are between those two numbers. So when you do that and you graph it, you can see, let's see here, that right there would be -1 1/6, and right here on our number line would be -1 5/6. And as you hopefully all remember, whatever number is to the right on the number line is always bigger. Okay, so -1 1/6 is a bigger number than -1 5/6. So the way that we would write that then is by using the less than symbol, because we would say the -1 5/6 is less than, or to the left of, -1 1/6 on the number line. Okay, then they give us another problem to try on your own, but they don't draw the number line out for us. They just give us the -6 and the -5, and you have to draw in the fractions in between. I've seen a lot of students have a hard time with this, so I'm going to show you a little trick to help you draw these. So what you want to do is, okay, this problem is asking us to compare the two numbers, -5 5/9 and -5 1/9. Okay, so as you can see, they already have a common denominator of 9. Whatever that common denominator is, or whatever that denominator is that you're working with, what you're going to want to do is take one number less than that, and that's how many dashes that you're going to need to put, or tick marks that you're going to need to put between the two whole numbers. So here's what I mean. In this case, our denominator is 9. So between the -6 and -5 on our number line, we need to put 8 little tick marks. 1, 2, 3, 4, 5, 6, 7, 8. Now, those should be evenly spaced. You can see I just kind of hand drew those in there. I didn't use any measurements, so it's not perfect, but I wanted to put 8 of the lines between there. And then I'm going to go ahead and number them. So as I move to the left on the number line from -5, the first fraction that I need to label is -5 1/9. Then -5 2/9. This is a little sloppy. -5 3/9. -5 4/9. 5/9. 6/9. I need a better stylus. -5 7/9. -5 8/9. Now, if you do -5 9/9, that's equal to -6. So that's why we know that we need one less little tick mark than what our denominator is. So again, that's just a little hint to help you, because I know sometimes those can be a little tricky to draw. So now we want to go ahead and graph. So -5 5/9, I'm going to find that on my number line right there. When you guys do this, when you use GoodNotes, it's helpful to use that shape tool as well. That'll make your lines a little straighter, and your number lines will be a little neater than what mine is here. Okay, and then -5 1/9 would be right there. So that's what our graph looks like, and now we need to compare. So again, whatever is to the right on the number line is going to be the bigger number. So -5 1/9 is a bigger number than -5 5/9. So the way that we would write this, we would say -5 5/9 is less than -5 1/9. Okay. So I hope that helps. Let's go on to the next one. And this example is a little bit different because we don't have a common denominator right away. So it's a little bit trickier because, as you can see here, we're comparing 7/12 to 8/18. And it's really hard to compare the fractions if we don't have a common denominator, okay? Hopefully, just by looking at this, you can see quickly that the common denominator here would be 36. So what we're going to need to do is convert these to equivalent fractions with the same denominator, okay? And they kind of show you the work here. They have it typed out. But basically, we're saying, well, what number do we multiply 12 by to get to 36? Of course, that would be 3. Whatever we do to the denominator, we do to the numerator. 7 times 3 is 21. So we take the fraction 7/12 and we rewrite it, let's see, I'll try red here, and I'll write above it. 7/12 would be the same as 21/36. Okay? Then we're going to go ahead and do the same thing for 8/18. Okay, we need a common denominator. That's going to be 36. How do we get from 18 to 36? We multiply by 2. 8 times 2, of course, is 16. So 8/18 is going to be the same thing as 16/36. Okay? Now, we could go ahead and draw a number line for this as well. Okay, these are two fractions that would be between 0 and 1. But whenever we have a common denominator, we can always just look at the numerators to compare the numbers. Okay, so 21 is a bigger number. Let's see if I can grab the highlighter here. 21 is a bigger number than 16. And since the denominator is the same now, we know that this would have to be, let's see here, greater than. Okay, 21/36 is greater than 16/36. Or, if we use the original fractions that were given, we now can see that 7/12 is greater than 8/18. Okay, let's try one more, and then I'm going to have you guys do 2 of them on your own. So the next one that they give us is 5/6 and 7/9. So the first thing we have to do is figure out, well, what's the common denominator? Well, hopefully you can see that that would be 18. So 5/6, to write that as an equivalent fraction with a denominator of 18, well, we would say, what do we multiply 6 by to get 18? That, of course, would be 3. 5 times 3 is 15. Okay, so this would be the same. 5/6 is the same as 15/18. I'll write that underneath. Okay, and then for 7/9, okay, we also want to get a denominator of 18. So to get from 9 to 18, we multiply by 2. 7 times 2 is 14. So here, this equivalent fraction would be 14/18. So now that we have the same denominator, we just have to look at the numerator to determine which one is bigger. Of course, 15 is a greater number than 14, so we would use the greater than symbol. 5/6 is greater than 7/9. Okay, now I would like you to pause the video and go ahead and try C and D on your own. And then after you've paused the video, come back and let's see if you got it right. Okay, let's see how you did. For C and D, I put the answers here. Both of them should have been greater than. So for C, the common denominator would have been 50. So the first thing I did is I took 1/5, the fraction 1/5, and I wrote the equivalent fraction of 10/50ths by multiplying the numerator and denominator by 10 to get 10/50ths. The fraction 7/50ths already had 50 as a denominator, so now it was just a matter of comparing the numerators. 10 is greater than 7, so we would use the greater than symbol. The last one was definitely the trickiest because it included or involved a negative. So the common denominator that I used was 160. So -9/16, I multiplied both the numerator and denominator by 10, and that gave me -90 over 160. For the -7/10, I multiplied the numerator and denominator by 16. 7 times 16 is 112. So now the reason that this one gets tricky is because we're comparing -90 to -112. Okay, so -90 is closer to 0. Again, think of the number line. Because we're dealing with the negatives, -90 is a greater number or a bigger number than -112. Okay, if you have any questions, please be sure to ask your teacher. I think since this video is getting a little long, I'm going to stop it here. This is the end of part 1, and in part 2 of this video, we will focus more on ordering or putting rational numbers in order from least to greatest or greatest to least.